Chapter 4. So Chapter 4 starts out by dealing with polynomial functions. So a polynomial function then is in the form of a and x to the n, a sub n minus 1, x to the n minus 1, a n minus 2, x to the n minus 2, so on, so on, and so on. Other type of function then is a power function, which is in the form of ax to the n. Right? So some various properties of a power function. And so the properties depend on the n. So if n is even, get one set of properties, and if n is odd, different set. So first off, if n is even, it is going to be symmetric with the y-axis. The domain is negative infinity to infinity, and the range will be 0 to infinity. The graph will contain the point negative 1, 1, 0, 0, and 1, 1. And the end behavior as x goes to infinity, f of x will go to infinity, and as x goes to negative infinity, f of x will go to infinity. Right? All right. So now if n is odd, so now it's going to be symmetric with the origin. The domain is negative infinity to infinity, and the range is negative infinity to infinity. It's going to, the graph will contain the points negative 1, negative 1, 0, 0, and 1, 1. And the end behavior as x goes to negative infinity, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. So then, given a polynomial function, can we identify the zeros? So given f of x equals 5x squared, x plus 2, and x minus 1/2 to the 4th power. Well, let's see, the zeros, that would mean either 5x squared could equal 0, x plus 2 could equal 0, or x minus 1/2 to the 4th could equal 0. So we're going to solve each one of these. So divide by 5, divide by 5. And then here we will subtract 2. And there we'll take the 4th root. So this is going to give me x squared equals 0. This will give me x equals -2. And this will give me x minus 1/2 is equal to 0. So here x is going to be 0. And this one, bring the 1/2 over. And we get x is going to equal 1/2. So the zeros are going to be -2, 0, and 1/2. Right? And then the other thing we could talk about is in terms of the multiplicity. And the multiplicity probably is related to the exponent. So here this is going to be 2. This is going to be 1. And this is going to be 4. Well, then we can talk about what does the graph of this thing look like. So we can make a chart. So we said our factors were the x plus 2, the 5x squared, the x minus 1/2 to the 4th power, and then our f of x. And we'll have a number line. The numbers we're going to have here are going to be -2, 0, and 1/2. Right? So we just want to know whether the term is going to be positive or negative. Right? So x plus 2, when we're a number less than -2, this will be negative. All right, and we want to do this in color. So this will be negative. This is going to be positive because after all, a negative number squared will be a positive. This will be a positive because we'll have a negative number raised to an even power, which will give us a positive number. So a negative times a positive will give us a negative number. Right? Well, when we're in between -2 and 0, now this will be positive. Now this is positive. This is positive. And now f of x will be positive. Okay? And then here, again, everything will be positive. And then here, everything is positive. Right? Right. So what does that mean in terms of if we were wanting to do a quick graph as to what is going on here? Right? So the numbers I want to put on here can be, this is -2. Right? And then we want our 0. And let's make this 1/2. Right? So our graph. So our thing is negative, and then it becomes positive. So it's coming in from here, goes through -2, and increases. And then it comes down from some point, and it's going to hit the 0. And what happens, because the multiplicity is 2, is it'll only touch the 0, goes up, comes back down, hits the 1/2, and then goes back up. Right? So if it's an even multiplicity, it hits the x-axis, but then bounces back. Right? So we get a graph that looks something like that in terms of a quick graph as to what we would get. Right? And then, of course, we get a more detailed graph by graphing this on a graphing calculator or on a graphing program online. So let's do that for a moment. And so let's go to this. So we're going to go here, and we are now going to go over here. So this is Desmos.com and a graphing calculator. So let's graph what we just did, my quick graph. And so we have y equals 5x squared, so we'll pull up this little toolbar here, times x plus 2 times x minus 1/2. And this is raised to the 4th power. And we get our graph. So it's coming in, goes up, passes through -2, goes up to whatever that highest point is. And let's see if we can get it on scale here or not. Oh, let's see, way up. There we go. Highest point is way up there, 102. And then it comes back down, so let's zoom in again so you can see what's happening here. So it comes back down, it touches the 0. Right? So it touches here at 0. So it touches here, bounces back up just a little bit, and comes back down at our 0.5. Right? So sort of like what we have here on my quick graph. Right? All right, so let's go back to our main screen. Right? And so now we're back here. All right. So then in terms of those things that are called turning points. Right? If the polynomial is degree n, then it has at most n minus 1 turning points. Okay. And then if the graph has n minus 1 turning points, then the degree is at least n. Other things we can do on Desmos is we can create scatter plots. And so they do talk about scatter plots a bit. So a scatter plot really is something that looks like this. You have your axis and you have just the points plotted on the graph. That is a scatter plot. So let's see how you do that on Desmos. So go back to Desmos. And we should be back over here. So we're going to do a scatter plot. So the first thing we do is type the word table. And it gives us an XY chart. And then we'll plug in some numbers here. So let's do 3, -2, -1. Let's do 2. Sorry, -1, 2. Let's do 0, 5, 1, 0. Let's do 2, -3, 3, -15. Right? Oh, right. -15. So we got some points plugged in. And then we click on this thing here, this zoom fit. It will close in on my points. So we can see we go up and we come back down. in terms of the shape. Right? And this shape would be sort of a U shape, which would be a quadratic. Right? We can also have Desmos tell us the equation that goes with this curve. And so we can go here, and we'll have y1, because my graph refers to our points as x1 and y1. And then the tilde, and my quadratic, which will be ax1 squared plus bx1 plus c. And we get our graph. So we get this. And so here's my curve that goes with my points. Okay? So Desmos will give us that too. All right, so let's go back to our whiteboard here. Right. So we're back over here. So other types of functions then they talk about here is then a rational function. So a rational function, just like a rational number then, is something that is in the form of a fraction. So we can talk about asymptotes of this. So first off, vertical and horizontal. So vertical asymptotes occur at all values of x that make the denominator equal to 0. So, for example, if we had this, r of x is equal to 4x squared plus 3x plus 9 over x plus 5. Right? Well, there will be a vertical asymptote at the value of x that makes this equal to 0. And so we have x equals -5. We could also have another one. Let's say I had this one. And we said, okay, so now you have f of x equals x squared plus 7 over x squared plus 5x plus 6. Well, again, is there values here that make this equal to 0? This thing is factorable. So we get x plus 2, x plus 3. So x plus 2 could equal 0. X plus 3 could equal 0. And we could solve each one of these. And so here we find out there will be two asymptotes. One at -2 and the other at -3. All right. So vertical asymptotes. All right. So the next one then are horizontal asymptotes. All right. So horizontal asymptotes. So again, given r of x equals f of x over g of x, which is a n x to the n, a n minus 1, x to the n minus 1, so on, so on, so on, over b sub m x to the m, b n minus 1, x to the n minus 1, and again, on and on, b1x plus b naught. All right. So there are three possible cases here. So first case, if n is less than m, then have a horizontal asymptote at y equals 0. Second case, if n equals m, then have a horizontal asymptote at y equals a sub n over b sub m. And then the third case, if n is greater than m, then there is no horizontal asymptote. Okay. So those are my possibilities here. So let's just look at an example of one of these cases. So let's say I had something like this. Y equals 4x to the fourth, 7x cubed, 2x squared over 5x to the fourth, 12x squared minus 21. Well, there will be a horizontal asymptote at y equals 4/5. The degree on the top is equal to the degree on the bottom. And so the asymptote is given by those coefficients in front of that highest degree term. And then the other type of asymptotes then are called oblique. Let's try that again. Oblique asymptote. So this only occurs if n is equal to m plus 1. So, for example, we have 3x to the fourth minus x squared over x cubed minus x squared plus 1. So the degree on the top is 1 more than the degree on the bottom. So to get the asymptote, we're going to do long division. So you get x cubed minus x squared plus 1. We're going to divide that into 3x to the fourth, 0x cubed minus x squared, 0x plus 0. So we're going to put these things in the 0x cubed, 0, and just the whole places. So we're going to do division. So let's see. What do I have to multiply x cubed by to get 3x to the fourth? And so that'll be 3x. The next step is dividing. So this is going to give me 3x to the fourth minus 3x squared plus 3x. And then the next step is to subtract 3x to the fourth minus 3x to the fourth is 0. 0 minus a minus 3x cubed is going to be 3x cubed, and I should change that. This should be a cubed. Cubed, there, get that in there better. All right. And then we have a minus x squared. And then we have a minus 3x. And then we divide again. And so what do I need to divide x cubed into multiply x cubed by to get 3x cubed, and that'll be 3. So this will be a plus 3. And so this will give me a 3x cubed minus 3x squared plus 3. And again, we want to subtract. And the x cubes go away. And so the minus x squared minus a minus 3x squared will be a 2x squared. And then this will be a minus 3x and a minus 3. And we can't divide x cubed and x squared, so at that point we're done. And so we have an asymptote at y equals x plus 3. And this will be our oblique asymptote. So let's go over here and see what that would look like. So let me quickly graph that here on Desmos, my original. Okay. So we want to graph this. So 3x to the 4th minus my x squared and divide x cubed x squared plus 1. Right? So let's go over to my graph. I have it graphed over here. 3x to the 4th minus x squared over x cubed minus x squared plus 1. All right. All right. And let me also put it in this here. Not working very well. No. 3x plus 3. That's why. All right. All right. So let's go to my graph. I got it all graphed now. So we should be looking at my graph, and so here's my curve. The green line is my asymptote line here. And so if we go here and we look over here, we can see that my curve is very, very close to my asymptote, right? And the same thing down here. I get down here again. We're very close to my asymptote line, right? So we have this asymptote, right? So we can do a graph, okay? And we can graph it on Desmos, all right? Or if you have a graphing calculator, we can graph it, all right? So let's do another quick one here. We do this one. And so y equals, we got 2x squared minus 5x plus 2 divided by x squared minus 4, right? And we get a graph. So let's look at what's going on here. Right? All right. And let's see, I think we need to finish this off here. Get this working. And we can get a graph. And so here we go. We have this graph. We look at this. Let's see. We have an asymptote here at -2. Right? So let's put that in. So x equals -2. Let's put that graph. Let's put that in. We can see where that asymptote line is. There's my asymptote line. Right? And the degree on the top is the same as the degree on the bottom. So that means there would be a y asymptote line. And let's put that in. That's going to be y equals 2. And so we have our two asymptote lines in. So again, if I scroll in, we can see we get very close, but we're not actually touching the asymptote line. Okay. Right. Well, then the other thing then is, okay, given a graph, what is a possible rendition of the function that went with the graph? Right? Right? So let's say we had a graph, and so let's go back to our other screen. Right? So now we're going to have, okay, given a graph, can we come up with a possible function that goes with it? So given the graph. So let's say we have a graph that is doing something like this. Well, let's see. So we want to have a few asymptote lines in here. 1, 2, 3, 4, 5. So we got an asymptote line going here. We have another one going here. We have one going here. Going this way, right? Got all my asymptote lines in. Now let's draw in the various curves. So we have a curve going like this. We have this one, which comes up, touches, and goes back down. And then we have this one, which goes like that. Right? So there's my curves. So what is a possible function here? Well, let's see. Well, let's see. In terms of crossing and my asymptote lines. So we have an asymptote line here at x equals 2. And another one here at x equals minus 5. Right? So that would mean that in terms of my denominator, okay, and what's going on here? Well, let's see. We have to have an x minus 2 to give me that one. We have to have an x plus 5 to give me the other one. Right? And then in terms of crossing my axes, we know that at 2 that we hit, at negative 2 we hit and we bounce back. So this is going to mean we have to have an x plus 2 squared. Right? Right. We know the degree on the top has to be equal to the degree on the bottom, right? But we want to have an asymptote at 2, because this is, so we want to have a 2 out front. So far we have something like that going at the moment. And let's see, what else can we figure out about this thing? And let's see, we got our asymptotes. We have that thing was so what do we have so far? X minus 2, x plus 5. So we could do in terms of what's going on with our curve here, right? Right, let's see. So if I pass. Right. So we want to see now, are we getting close to what we want? All right. So we got, let's see. So we need to sort of make this match. So we need this to have, we're going to have an x minus 5 term up here. Maybe. Oh, actually, I think I need to go back to my screen, right? Yep, up we are on the main screen. Okay. So we want to have, this will be now an x minus 5 in order to get this downward curve. But then the degree on the top is 3. And so we match that way, and we get a possible equation that goes with our graph. We end up with that. Right? All right. Oh, let's see. And then you have in terms of solving an inequality. Right? So given something like this, x to the 4th greater than x. So x to the 4th minus x is greater than 0. We could factor out an x. So x has to be greater than 0. X cubed minus 1 has to be greater than 0. Right. And so we could solve each one of these. So that's already solved. So this means x cubed has to be greater than 1. And x would have to be greater than 1. Right? So in terms of our intervals then, well, we have one interval will be negative infinity to 0. Another interval will be from 0 to 1. And another interval will be from 1 to infinity. And we can ask to say, okay, what's going on here with our functionality? Well, negative infinity to 0, that will end up being a positive number. Between 0 and 1, this thing would end up being a negative number. And then greater than 1, we're back to being a positive number. Right. So let's look at another problem. So let's say we now have this. 3x squared plus 13x plus 9 over x plus 2 squared less than or equal to 3. So 3x squared plus 13x plus 9 over x squared plus 4x plus 4 minus 3, 0. Again, or the add or subtract, we need to have a common denominator. So this will be 3x squared plus 13x plus 9 over x squared plus 4x plus 4 minus 3 times x squared plus 4x plus 4 over x squared plus 4x plus 4. Right. So this will be 3x squared plus 13x plus 9 minus 3x squared minus 12x minus 12 over x squared plus 4x plus 4. Simplify. And so 3x squared minus 3x squared, that goes away. 13x minus 12x will be x. 9 minus 12 will give us a minus 3 over x squared plus 4x plus 4. Right? Well, the only way this can be 0 is if the top goes to 0, and so x equals to 3. We'll make that a 0. Okay? We also know that this thing is going to be undefined at x equals negative 2. So we have negative infinity to negative 2. We have negative 2 to 3. And then we have 3 to infinity. Right? Well, negative infinity to negative 2, this will end up being a negative number. Between negative 2 and 3, it's also a negative number. And when we get greater than 3, we do become a positive number. So division, then. So f of x over g of x is going to be the quotient plus the remainder over g of x, or f of x is equal to q of x times g of x plus r of x. Right? So if x minus c is a factor of f of x, then f of c is equal to 0. So given that f of x is something like this, 2x cubed minus x squared plus 2x minus 3. And the question then is x minus 1 a factor? Right? So that would mean then that 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. And this does indeed equal 0. So x minus 1 is a factor, right? And then is x plus 2 a factor? Right? So that would mean here that c is going to be negative 2. So this is going to be 2 times negative 2 cubed minus negative 2 squared. 2 times negative 2 minus 3, which gives us a negative 27. So this is not a factor. So then a polynomial will have at most the same number of zeros as the degree. So how do we find those zeros? All right. So potential rational zeros. So given something like this, f of x equals 2x cubed, 11x squared minus 7x minus 6. What are those possible zeros? To do that, we need to look at the leading coefficient and our constant number. So the p is going to be that constant number, and the factors of 6 are going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then the q is the front number coefficient, which will be plus or minus 1 and plus or minus 2. Okay, and then the possible is going to be given by p over q. And so this will be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, and then plus or minus 6 over 2. And then we could simplify this list. And so we're left with plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, and plus or minus 3/2 are the possible zeros we could have for this one. Which still gives us a lot of possibilities. We have 1, 2, 3, 4, 5, 6, 7. Right now we have 14 possible there. If you think about the plus and the minus possibles here. So how can we also maybe cut that down a bit? So you get to this thing, discard rules of sign. Okay. So the number of positive real zeros equals the number of sign variations or less than by an even integer. And then the other part of it is the number of negative zeros negative real zeros, let's stick that in there, all right, equals the number of sign changes of f of minus x or less than an even integer. So let's go back to the problem we were working and see if we can figure this out and see if we can narrow this down a bit. So let's write down our function again. So we had f of x was equal to 2x cubed plus 11x squared minus 7x minus 6. So first off, let's look for the positive real zeros. Well, let's see. We start positive. We're still positive. Then we become a negative. So we have one sign change. And that's it. Okay. So there's going to be one possible positive one. And now how about the negative one? Right. So negative. Well, to do the negative, we need to figure out f of negative x. So this is going to be 2 times negative x cubed, 11 times negative x squared minus 7 times negative x minus 6. Right? Well, what is this going to give us? This is going to be a minus 2x cubed plus 11x squared plus 7x minus 6. Now we want to know the number of sign change. Well, we go for negative, positive. That is 1. And then we go to negative, so we have 2 sign changes. So 2 sign changes. So the number of zeros can either be 2 or 0. Right? Right? So there's going to be 1 positive, 2 negative. Right? Well, now it's a matter of figuring out what they are. So we have our list. Right? So let's write our list again. We said plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, and plus or minus. So now it's a matter of just start testing. So let's first test the easiest number, which is 1. So we want to know, okay, is x minus 1 a factor? So if I do that, well, we could do that by plugging in and say, okay, well, that would mean, okay, 2 times 1 cubed plus 11 times 1 squared minus 7 times 1 minus 6, and that indeed will give us 0. So x minus 1 is a factor, all right? So that would mean I know that x minus 1 has to be able to divide into this. So let's see, I got to multiply, what do I need to multiply x by to get 2x cubed? So that is going to be 2x squared. So this is going to give me 2x cubed minus 2x squared. Then we're going to subtract. The x cubes go away. 11x squared minus a minus 2x squared would be 13x squared. And then bring down the next term. And then I need to multiply x by a 13x. To get that. So this will give me 13x squared minus 13x, and again we want to subtract. X squares go away, and this will give me a 6x. Oops, sorry. We want to do that back in black. So this will give me 6x. Bring down the 6. And then we need to multiply x by 6 to get 6x. So plus 6. So this will be a 6x minus 6. And then we want to subtract. And the result here is 0. Right? So we get 2x squared plus 13x plus 6. So now we can look at that. Okay, so now, when is this going to equal 0? And it ends up this is indeed factorable. We're going to get a 2x plus 1 and an x plus 6. And then we could solve each one of these. So either 2x plus 1 equals 0, or the x plus 6 equals 0. And solve each one of these. So you get 2x equals minus 1. X equals negative 6. Divide by 2. And x equals negative 1/2. Okay. So we found in terms of our zeros here. Okay. And then the last thing this chapter finishes off with is a thing called the intermediate value theorem. Which says if f of x is continuous on the interval a to b, and f of a is greater than 0, and f of b is less than 0, then there has to be a value c such that f of c equals 0. Right. So if I have a graph, it goes from positive to negative or negative to positive, then there has to be where somewhere in there we're across the x-axis. Right? And that will conclude this video.